Hey class.
The product rule gives us a way to take the derivative of a function involving the product of two terms. There are cases where multiplying out is easier to do first, then use power rule. We will look at cases when it's easier or when it's easier just to apply product rule. Let's let f be a function that's the product of two terms, a and b. Then that function, AB, which A and B are going to represent different algebraic terms. But if it's a product of two terms, then our derivative using product rule, our function's derivative will be the derivative of the first term times the second plus the first term times the derivative of the second term. Example, find the first derivative of the function by multiplying, then use the power rule, by multiplying, then using power rule, then by product rule and simplifying. So we're going to do it two ways. If it works out to where you can do it both ways, you pick which way you like better. So I'm going to take a function that is a product of two terms. I'm going to call this first set of parentheses the A. That way we get this notation at the top. And the second term, I'm going to label it with a B. So this function is now AB. A is 2x minus x cubed. B is 3x plus 4. When we take our first derivative, using product rule, we have the derivative of the A set or group. The derivative of 2x minus x cubed is 2 minus 3x squared. B gets left alone, plus, now we're going to leave group A alone, times the derivative of the B group, which is just 3. So in green, I highlighted the A and the B terms that we have a product of. A prime B plus A B prime. That's the product rule expansion. Now when we FOIL, we have 6x plus 8 minus 9x cubed minus 12x squared. So those are these first four terms. Plus, the second group, we only distribute the 3, so that's going to be 6x minus 3x cubed. Combining like terms, we have negative 9x cubed minus 3x cubed. That's negative 12x cubed. There's only one x squared term. Recopy it. There are two terms that are x, 6x plus another 6x. That's 12x. And there's only one constant, 8, so make a copy. This is our first derivative using product rule. Now, if we had chosen to multiply first and then use power rule, this is how it would play out. It's the same problem, it's just we're going to do it in a different way. If we start out by multiplying using FOIL method, we have 6x squared plus 8x minus 3x to the fourth minus 4x cubed. There's only one x to the fourth term, make a copy. There's only one x cubed, only one x squared, and finally only one 8x or linear term. This is the product of those two terms. We have yet to take a derivative, and this is where power rule comes in. Take each term and its derivative, we get negative 12x cubed, negative 12x squared, plus 12x, plus 8. So there are times, and I would argue that it's easier on this one to multiply your terms out and then take the derivative of your answer. There are times when we can't, and in a future video or future lectures, we'll see cases where we can. The product rule, it does come in handy. You see it a lot in mathematics. We're just going to do another example going both ways. We're going to use the product rule, and then we're going to multiply and use the power rule. So we're going to take a function that's a product of two terms, 7x minus 5 times 3x plus 1. So we have a product of algebraic terms. Derivative of the A group is 7, B gets left alone, plus A group gets left alone, times the derivative of the B group, which is 3. If you only multiply by a constant, then you use distributive property, so 21x plus 7 plus 21x minus 15. Combining like terms, 42x total, 7 minus 15 is negative 8. If we multiply first and then use power rule, then we use the FOIL method if you're multiplying two terms times two other terms. So our first terms, that's 21x squared. Outer terms is 7x. Inner terms, negative 15x. And last terms, negative 5. The outer and inner terms are like, so we have 21x squared. This totals to negative 8x minus 5. Again, that's just a product. Now taking the derivative, we get 42x minus 8. So the derivatives are the same no matter which way you proceed. And some problems are very generous where you can use product rule right off the bat, or you can find the product of the terms in your function and then take the derivative of that product. A few extra examples of product rule. Now these, when we did them in class together, you guys chose to multiply first, then take the derivative. And on this example, that was very wise. 7x to the 5th minus x squared. And then those two terms, you can take the derivative using power rule. 35x to the 4th minus 2x. That was a good choice. If your function gets more and more complicated, then I always say the more complicated your product is, the better off you'd be just to do the product rule. Again, you be your own judge. When you pick a way, or do them both ways and see if your answers match. That's kind of the safety net. Using product rule, we have a product of x squared minus 4x plus 6 and x cubed minus 6. So I label the first group A, the second group B. The derivative of our first group is 2x minus 4 times the second group left alone plus the first group left alone times the derivative of the second group, which is 3x squared. Multiplying out, we have 2x to the 4th minus 12x minus 4x cubed plus 24. And then the back group, we have 3x to the 4th minus 12x cubed plus 18x squared. Combining like terms, we have a total of 5x to the 4th terms, a total of negative 16x cubes, only one x squared term, so just copy it if there's only one term like it. Same thing with our linear term, negative 12x, there's nothing to pair it with. And then also the constant 24. So there were only like terms for the x to the 4th and the x cubed. I hope this video has helped out a little. If you have any questions, reach out by email or phone, or if we're having a traditional class together, be sure to ask in class.